Hello, my name is Ima Frank, your regular tutor. In this package, we are going to look at calculus of several variables, also known as a mass method. Now, I will urge you to sit down, bring your book and your Bible so that you can put down all the things that I'm going to teach you on this particular course. Thank you. Before we start, let's look at the format of the teaching. The course is calculus of several variables. Then we look at behavioral objectives. At the end of this teaching, the students should be able to evaluate functions of several variables. The students should be able to evaluate implicit function of several variables. The students will also be able to evaluate the Jacobian of functions of several variables. The students should be able to perform integration of functions of several variables and a lot more that we are going to learn. These are the objectives. Before talking about functions of several variables, I'd like to relate us to what we know in elementary calculus, which is function of one variable. Now, consider these two sets. I have set x. Set x is minus 2, minus 1, 0, 1, 2. It is a set, and it has this element. We know elementary sets. Now consider another set, set y, which also have 1 as its element. Now 2 also have 5 as its elements. Now suppose I put these two sets in this form, and this is set y, and this is set x. Now, the elements of x are minus 2, minus 1, 0, 1, and 2. And I have here 1, 2, 5. Now, there's a rule that is assigned these elements. There's a relationship that exists from these sets x to set y. Now this side is called the domain, and this side is the co-domain. I'm trying to talk about in terms of mapping so that you know what we are talking about here. Functions of several variables. So I'm relating us to mapping. Now this element is mapped to here. 2 is also mapped to here. 1 mapped to 2, even minus 1, so mapped to 2, and then 0 mapped to 1. Now, question may arise, how is this one mapping to this? And so, we don't want to go into that because we will have our lectures on numerical method, that is a numerical analysis, mathematical method, mathematical analysis. Will tell you about this function that I want to write now, how you can find out how function, you can bring out the functions that exist between these two sets. But let's just look at what we are about doing, that if I have x squared plus 1, now this is what I'm saying. To bring out this function, you can learn that in numerical analysis. If I have two sets like this, to bring out the function that bring the relationship. Yes, it's easy to do. So it's not part of this course. So you just accept this. Now, if I put minus 2 in this place, so I have minus 2 squared plus 1. And that will give me 4 plus 1, which is 5. So you see how minus 2 relates to 5. Also, if I put minus 1 squared plus 1, then I will have 1 plus 1, which is 2. So that is why minus 1 relate to 2. If I also put 0 squared plus 1, then I will have 0 plus 1, which is 1. So 0 moves to 1. Now, if I put 1 squared plus 1, I will have 1 plus 1, which is 2. That's why 1 also maps to 2. Then, for 2 squared plus 1, I have 4 plus 1, which is 5. So 2 maps to 5. Then what I observe is that I can confidently say that y is equal to x squared plus 1. And look at that. Y is equal to x squared plus 1. You know, the reason is this. You see, when x is minus 2, y is 5. When x is minus 1, y is 2. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 5. You see, y doesn't have choice. It's only what x is giving y that y is accepting. Only what x is giving. That is where y has its value. When x gives another value, y has another value. So in that case, y is a function of x. Now in layman language, we say that y depends on x. But in mathematics, we say y is a function of x. So what is function now? Something that depends on another thing. So y is a function of x because y doesn't have any say. It's only what x gives that y become. And so we write this. We write this that y is equal f of x. Don't forget there's a rule f that is generating it. So y is equal f of x. This is what we did in elementary calculus. We differentiate y with respect to x, which is one variable. So in this course, we are going to see functions that are more than one, that depends on more than one independent variable. Functions of several variables. So here y is function of one variable. Okay. Now let's look at it. If I write that z is equal f of x y. So here z is a function of two variables, which is x and y. Now if I write that z is equal f of x, y, and then w by like. So here z is a function of x, y, and w, depend on 3. So in general, z is equal f of x1, x2, x3, x4 till we have xn is said to be function of n variables. Now there are some things that are not function of one variable. Many things in the world, they don't depend on one. They depend on this and they also depend on another. By the time we look at our package that we have for applications, you will see such things. For instance, let me give you one. The volume of a cylinder is given by V is equal pi radius squared height, where R is the radius and then the H here is the height. You see that the volume of this cylinder is not function of one variable. It depends on the radius and the height. So now if I bring a cylinder, the volume of that cylinder and the volume of another cylinder that I also bring will differ based on the radius that each cylinder has and the height. The bigger the cylinder, the bigger the volume. If it is small cylinder, then the volume becomes small. So what it means is that the radius decide what the volume will be. The height also decides. It's not only one variable. And so we can write this. We can write volume for volume, that V is equal F of R H. You see, if we write like this, what we are saying is that volume is a function of radius and height. So these are things we are going to look at. Functions of several variables, things that depend on several variables. And so here, V is a function, and it is called dependent variable, while R and H are independent variable. Such that happen here. Y is dependent variable, while X is independent variable. X doesn't depend on Y, it's only Y that depends on X. So most things in the world today is like that. If you look at in school, even in school, most students are functions because they depend on their parents. There are some students that depend on only a father as a source. So that student is a function of one variable. So some depend on their uncles, their mother, so there are functions of several variables. So those things are what we are going to study so that you really understand the concepts, what we want to look at. Let's look at this. V, we know that the volume of a cylinder given by V is equal to 5 radius square height. Now, if R is equal to 5 meters, and then H is equal 10 meters. H is equal 10 meters. Then we can now get the value of this function V, the volume, of V. That would be V will be equal pi radius square, that is 5 square times 10. And here we have that V is equal pi, then 25 times 10, which will give us that V is equal 250 pi. So this is the volume meter what cube. So this is the volume now that we have. You can see that now if radius is 2, for instance, and then H is say maybe 6. Is it that we will not have 250 pi meter cube? We will not have because that one makes it small. So the volume now depends on radius, the value of the radius and the value of the height. So these are what we are saying. Now we also look at another example in evaluation, in general mathematical evaluation. We look at other examples that we can evaluate this time. Thank you. So let's look at this example. Given that f of xy is equal to 3x squared minus 4xy minus y squared, find f of 0, 0, f of minus 1 and 2, then I will have f of x squared and 1 over y. So we take the solution. Now this function is a function of two variables x and y. See? So we have that f of xy is equal to 3x squared minus 4xy minus y squared. So f of 0 and 0, meaning that the value of x is 0, the value of y is 0. So we have 3, 0 squared minus 4, 0 times 0 minus 0 squared. Of course, everything gives 0. Then for I, that was I. For I, we have that f of xy is equal to 3x squared minus 4xy minus y squared. Therefore, f of minus 1 and 2 will be 3. Then we are going to put minus 1 in the place of x. Now we have minus 1. So minus 1 squared minus 4 minus 1. Then we have 2 in place of y minus 2 squared. Then we will have that f of xy equal 3 times 1 minus 4. Okay, so if we times this 2, we have minus 2. then minus 4 because of 2 square. So we have 3 plus 8 minus 4. Okay, so this is 11 minus 4, which is 7. So in this particular value, the value of f is, the particular evaluation, the value of f is 7. So now let's go to add, which says that f of xy is equal to 3x squared minus 4xy minus y squared, and that the value of x and y is given as x squared then 1 over y. So this will give me 3, then the x squared minus 4x squared, then y is given as 1 over y minus 1 over y squared. So what I will have here is 3, then this one will give me x raised to the power 4 minus 4x squared over y minus 1 over y squared. So at this particular point, f of x squared 1 over y is given by this. You know, the given value was variable, so it also have the value as a variable. So this is how to evaluate functions of several variables. We have so many, so you can use this to look at other examples and then you evaluate it. Now this 7 is called the value of the function. 0 is the value of the function at this given point. So this is how we evaluate functions of several variables. So let's move to another subtopic. The next subtopic looking at is conversion of function of several variables to function of one variable. Now function of several variables can be converted to function of one variable using appropriate substitution. Of parametric equation. So when we are giving functions of several variables, if we are also giving parametric equation, we can convert it to function of one variable. So a practical example of this we show. We are going to take example so that we see how we convert function of several variables to function of one variable. Okay, we look at this example. Convert the following functions of two variables to function of one variable. Here we have f of xy is equal to x squared minus 2xy plus 4y. Then x is equal to t, y is equal 1 over 2t. We have f of xy is equal to x squared minus 2xy plus 3y squared. X is equal to t squared, then y is equal minus t cubed. Now let's start with solution. We have f of xy is equal to 3x squared minus 2xy plus 4y squared. And we are given this parametric equation. This is what we call parametric equation. That x is equal to t, and then y is equal 1 over 2t. So what it means is that in every value of x, we will have t. And if we do that, we have 3t squared minus 2t. Then we have 1 over 2t in the place of y. and then we have 4, 1 over 2t squared. And this will give us 3t squared minus 2 over t. Okay, minus, okay, this 2t can cancel 2t. So we have minus 1. Let's just put 1 here, because this can cancel this. Plus, then here again, we have 4, 1 all over 4t. That is what it means. Because 1 square is on 4 square t square. Okay, so 1 over 4t square. Which we know this can cancel this. So we'll have 3t squared minus 1 plus 1 all over t. Or 1 all over t squared. 1 over t squared. Because this 4 and cancel this 4. So we have 1 over t squared. Okay, so this means 3t squared plus 1 over t squared minus 1. Alright, so it's the same thing as this function now. It means that f of xy is equal this. Is equal this value. So that is how we evaluate it. Now you can now see that this function now is the same as writing as one function. So this function becomes f of t is equal 3t squared plus 1 over t squared minus 1. You can write like that. So this function is the same thing with this. At the point here x is equal t and y is equal 1 over 2t. So we are converting it now. Now for I like you to take I as your own exercise and practice it. It's just very simple. Just substitute t squared in place of x, then substitute minus t cubed in place of y. Very simple to me. Okay, so we look at another subtopic.